Yesterday in Lesson 5, students started investigating the distributive property by breaking apart one factor, which was a two-digit factor. For instance, 16 times 4. By breaking apart the 16 into two smaller add-ins, like 10 plus 6, students were realizing that they could do two smaller multiplication problems to get this bigger problem that isn't a basic fact, like 16 times 4. We were using strategies based on place value and understanding the operations of multiplication and addition. And we were multiplying a whole number up to 2 digits yesterday. Today we're going to take that number and move up to 4 digits, using the strategies we learned yesterday and taking a closer look at what the distributive property is. So to start, we reviewed by looking at the actual definition of the distributive property, which we color-coded to make it a little bit less confusing and easier to understand in steps based on the strategies we learned yesterday. So multiplying a sum by a number is what we see in this red. We're multiplying the sum of 10 plus 8, which is 18. And we're multiplying it by the number 7. So instead of 7 times 18, we're taking that 18 and we're finding two add-ins that we can break apart into two smaller problems. Yesterday we were using the grid paper to help us keep track of how many rows and how many were in each row to see that multiplication and how it's tied to an array. So breaking this apart, we can break it up into 10 and 8. And so far, we've done the first part of the distributive property. We're multiplying a sum by a number, which is the same thing as multiplying each addend by the number. So this number is 7. The addends are 10 and 8. Because 10 plus 8 gives us the sum of 18. By finding these two products, which are called the partial products, we can then add them to find that 7 times 18 equals 126. Looking at the distributive property, we also reviewed looking at it in equations and finding missing numbers to help us get familiar with this distributive property. So looking at this number here on the left of the equal sign, we want it to be the same as the right side of the equal sign because that's what the equal means. It means the same as. If we look at this problem, the 3 times 10 plus 7, that's the first part of the distributive property. It's multiplying a number, 3, by a sum, 10 plus 7. So looking at this, we're multiplying 3 times 10, which was the addend, and 3 times 7, which was the other addend. For this problem here, the addends are 9 and 5. So we're multiplying 9 and 5 times 8. Thinking back to the rectangle that we had, we would multiply 8 times 9 and 8 times 5. So looking at this sentence here, it fits nicely. 8 times 9 plus 8 times 5 will give us the same problem. So looking at today's lesson, we're just taking the numbers to the next place. Instead of a 2-digit number, we're looking at a 3-digit and a 4-digit number, multiplying by a 1-digit number. Using the place value, understanding of expanded form, students are going to start breaking apart 143 into hundreds, tens, and ones. Just like yesterday, we were breaking apart a factor here so that we could have 9 plus 5. We weren't using the expanded form here, but in another example, this is our expanded form, 1 10 and 8 ones. So it's really the same strategy we were using yesterday, but we're taking it to the hundreds and the thousands. Using that understanding of breaking apart 143 into 3 smaller numbers, and also with our understanding of multiplying large numbers with zeros, this problem becomes a lot easier. To do 5 times 143, we want to take this expanded form, and we don't need a grid paper anymore. We want to move away from the grid paper and get students to understand that by labeling the numbers on the outside, we can just assume we know there's a lot of smaller squares on the inside. So our outside rectangle, we're going to break up into hundreds, tens, and ones. Now instead of 2 smaller problems, we have 3 smaller problems. This is just like the distributive property. By breaking apart the number into 3 add-ins, 100 plus 40 plus 3, we can multiply each one of those add-ins by the number 5. So the distributive property tells us that 5 times 100 plus 5 times 40 plus 5 times 3 will give us the answer to this original problem. And these numbers here are our smaller problems in the rectangle. 5 times 100, 5 times 40, and 5 times 3. Knowing our patterns with zeros, this is 500, 5 times 4 is 20, and add 1 0, and 5 times 3 is 15. Students then can add these 3 numbers, 500 plus 200 plus 15. Those 3 numbers are our partial products, so the answer is 715. 5 times 143 is 715. This example was in the student's spiral, so we took it step by step, looking at one square at a time, 5 times 100, and then in the next one, 5 times 40, the last one, 5 times 3, and in the last example, we added them all together, all the partial products, and got our final product. Also in the student spiral, we did this example where the distributive property is shown. We're going to use the expanded form. The number that we're multiplying is 4. We want to break up 213 in expanded form with 3 add-ins. So 200, 10, and 3. That is the same thing as saying 4 times each of those numbers. 4 times 200, 4 times 10, 4 times 3. That would also look the same if we were drawing our rectangle as you saw above, breaking apart the 3 numbers. So we have some really easy mental math numbers to work with. We're multiplying 4 times 200. 4 times 2 is 8 with 2 zeros. 4 times 10, and 4 times 3. Those 3 numbers are our partial products, and so now we can add them together. 800 plus 40 plus 12. So our answer, 4 times 213 equals 852. For our last example, we looked at what it would be with a word problem. The gift shop at the animal park orders 3 boxes of toy animals. Each box has 120 toy animals 1,250 toy animals. How many toy animals does the shop order? Since the 3 boxes of toy animals have the same number in each, it's like adding 1,253 times. Repeated addition is the same thing as multiplication. So the problem we're looking at is 3 times 1,250. By using the strategy of expanded form and breaking apart numbers, this time we'll break it apart 1,000, 250, and we have 0 ones. Some students like to include 0 in their rectangle. Other students know that since 0 times anything is 0, they don't actually need to write the 0 in their rectangle. It doesn't matter which they prefer. So with the distributive property, it's really 1,000 plus 200 plus 50 plus 0, and we're adding each of those, or we're multiplying each of those by the number 3. We find the answers to each, and you'll see that students are starting to understand what partial products are, and our partial products are the products of this number, this number, this number. They're partial products because they're 3 smaller answers to multiplication problems that we can then add together. So writing 3,000, because 3 times 1,000 is 3,000. 3 times 200 is 600, and 3 times 50 is 150. It's important for students to line up their digits when they're adding. They can find the answer that 3 times 1,250 is 3,750.